Hey everyone, looks like I'm back because I made a mistake in the solids and tortoiseshell episode. Yeah, turns out I didn't fully understand the red gene as much as I thought I did. So, my apologies everyone. For almost 3 years I had led people astray. Let me redeem myself by educating you properly on the red gene and how it interacts with cat genders. Yet, here's the thing. I did get the kittens right and what they would look like on the outside. I just got my calculations and genotypes of the parents mixed up. In the episode Solids and Tortoiseshells, it is still correct that red is dominant to black and the allele for red is big O. However, I did not fully understand how it worked with the two sexes. You see, red is a sex-linked trait, which means it's only carried through the X chromosome, as I had explained in the episode. However, they interact differently between the two sexes. As you may remember, when it comes to sex chromosomes in cats, females always have an XX chromosome and males always have an XY chromosome. And as I also mentioned in the episode, the mother determines the son's colors. While most genotypes for colors have two alleles, like big B for black and little d for dilution, it works a bit differently in cats and the red gene. In males, they only have one allele for red. They will either have a big O for red or a little o for non-red. So in the case of the mother passing on the red allele, they'll have a big O from the mother's X chromosome and nothing from the father's Y chromosome. And in the case of the father being red, since he only passes the Y chromosome to his male offspring, the male will get his color from the mother. But things are a bit different with female kittens. Females have two O alleles. This is due to both the mother and father giving them an X chromosome each, which contains the color. And how the O allele is presented determines 3 things. If the female is big O, she will be red. If she is big O, she will be a tortoiseshell or calico. And if she is little o, she is non-red and will be black, or a variation of black like chocolate and cinnamon. This is why male calicos are so rare, as this usually means they have the phenotype XXY. So one red X, one black X, and the colorless Y making it male. But the result of this creates a sterile male, or unable to reproduce. I go into more detail on how a male calico can produce offspring in my very first video, The Genetics of Lisa and Lewis, if you want to know more about that particular subject. So males only have one O allele, while females have two O alleles. So how does that work when it comes to Punnett squares and predicting what male and female offspring will look like? So there are 2 methods, a more professional method and my method. I will offer both to you to give you an option of how to use either to help you understand better. Let's go back to the first and original example I put in the first episode, the red male and the black female. I was correct in the male's phenotype of big O, big B, big D, little d, but I was incorrect with the female's phenotype, as it should have been little o, big B, big D, big D. So when we plug in the numbers, we've got something a bit odd. You got big O, big B, big D, big O, big B, little d, big B, big D, and big D, little d for the male, and only little o, big B, big D for the female. That can be confusing for anyone who's just beginning to understand genetics. However, for the male, you can also put a dash right before big B, big D, and big B, little d to represent the missing O allele. As a result, you'll get both phenotypes for each sex of kitten. The first 2 represent any female born from these 2 cats, born with phenotypes big O, big B, big D, and big O, big B, big D, little d, resulting in 100% black torties with 50% carrying dilution. The last 2 represent any male born from the 2 cats, born with little o, big B, big D, and little o, big B, big D, little d, resulting in 100% black and 50% carrying dilution. Here was the method I was using. I would make 2 Punnett squares, one for the mother and father cat's genotypes, and one for the sex chromosome with a colored X. I would give each parent cat 2 O alleles. I would complete the Punnett square. Then when figuring out the genotypes for male and female, I would compare the genotypes to the sex Punnett square. If the results lined up that a red male cat can be born, I'd leave the genotype as it is with at least one big O allele. When the results showed that a red male wasn't produced, and the genotype showed one big O allele, I would just cancel out the big O and leave the little o. The more I try to explain my method, the more I realize how confusing it is. You know what? You don't have to use my exact method. If you're confused, definitely use the colored X chromosome sex Punnett square to give you a short answer. But if you want the long answer, you're probably better off using the professional method. It may be confusing at first, but just putting in a dash just helps when determining male colors. And that's it. There's not much to add. Again, I'm sorry for misleading people for these almost 3 years. Thank you, Sharkdom, for pointing out my mistake. So further on, if you see little o, or big O, little o in the rest of the series for a red male, or just one O allele for females, those are wrong. But the phenotype results are still correct. So thank you for your time, and enjoy the rest of the series.